weakness শুরু হয়েছিল স্ট্যাটিস্টিকে প্যারামিটার estimation দিয়ে. So what is parameter estimation? Parameter estimation is, what the thing is tell is that we are using it to find a value of a certain thing. So certain distribution or certain thing, it can be mean, it can be variance or something that is not sure. But what we need to do is that estimator parameter is something by which we are trying to know about some unknown parameter, about the some value of any unknown parameter that we used to know by parameter estimation. So now, what is the estimator? So estimator is like a function of parameter which takes all the speciality of a parameter and then put it in a form which will give you the best result according to it. It has to be reliable, it has to vary with the values when they are varying, and then it should not have very big deviation from the actual value. These are the properties for the estimator. So first of all, the examples that we are taking here is that who is the best captain for the Indian IPL. So how we are taking and we're saying that Mahendra Singh Dhoni is the captain. So that's for that reason we need to take some values and then evaluate some parameter based on some estimator, and then come to a conclusion. By any bias thinking, that will not gonna give you the result. So what the processes are there is that first we need to collect the data of the run or score sheet or something. We need to analyze those things. We need to analyze those things and study the data like descriptive stats, histogram, scatter plot, and all those things. Then find the parameter which will fit the model, and then we can come to a conclusion. এবং কনক্লুশন আসার পর এখানে আমাদের যেটা বলা হয়েছে রিলেশনশিপ যেখানে আছে কাস্টমারের জন্য. সো দ্য সেকেন্ড থিং যেটা আমরা দেখেছি সেটা হচ্ছে হোয়াট ইজ রিমোট প্রক্টর এক্সট্রাম সাকসেসফুল. তো সাকসেসফুল রেশিওর জন্য উই আর টেকিং দ্য প্যারামিটার্স অ্যান্ড গেটিং দ্য ভ্যালুজ অ্যান্ড টেকিং. And now for coming to the conclusion part, one more thing that we need to consider is that how we are communicating, how we are giving the data, because there is too many ways through which we can give us the data, but which will give you the certain value. Like you can say that 100% increase in remote copter honor code violation, that doesn't mean you something unless and until you specify the end, the value of students. Like for 100 student, if previously there was a one honor code violation, now it is 100% increase, like now it is two honor code violation. So that is not something among 1000 there is two, so that is 2 by 100, 0.02%. That is not a very big deal, but when you say 100% increase, it conveys on some other data. So that's why it is not a very good way to communicate with other people. Okay, in this way you can just go to the real life problems and just relate it with the statistic. Now the second section where we are talking about the introduction to parameter. So parameter, what I have said, the parameter is something through which we are trying to evaluate any unknown parameter, unknown value. Sorry, parameter is something by which we are trying to evaluate any unknown value or something. So like for first example, we are taking a Bernoulli p trial. Bernoulli p trial, now we are taking p. Like p mean the value of success, that what is the p. So in a Bernoulli set of trial, there is success or failure, there can be n set of values like 1001 or something like 0001 or something, any set of values. Now I have to guess the p. So how we can guess the p? For that we need estimator, and we need a good estimator through which we can evaluate the values. And first thing that we can see, that the random variable Bernoulli, so what value it can take, it can reflect value between 0 and 1, and p is the parameter of the distribution that you know. Now, so coming to this part, the emission of alpha vertical, there is a second example that emission of alpha vertical that is said, and now we have to model it through a Poisson simply. Now in Poisson, what is the Poisson value of lambda? Lambda value, that is parameter that we need to estimate. And can we find a good estimator through which we can find the values that we need to consider? Coming down to the part where it can be said. So now it is another example of a voltage of a circuit. Here two things are parameter, that is mu. Mu is also a parameter, have an average value of the voltage and current that have to be calculated. And then sigma square, that can also be a parameter, very simple. Then 10 measurement we are taking, and we're just gonna simply find out the parameter. So this is the vital and crucial part. So x1 x1, that is id example. So now parameter we are just taking as theta 1 theta 2 simply. Now parameter estimator. So now what is the thing that is you need to consider here very well. So estimator for which parameter, for a parameter theta. So parameter theta we are taking the estimator. So what is estimator? Estimator is a function of random samples. In a binary tile there can be nth sample from which one function of a random sample, that is a estimator. So it can be very much random because we can take a random values from a samples. So like Bernoulli, so theta is a constant parameter because theta is a parameter that will take a single value, but through which how much, in how many ways we can take the value, it can be calculated by the estimator. So estimator we are taking as theta hat. So theta is a random variable. Well, now see, these are the estimators for a parameter p, Bernoulli p. So Bernoulli, you know, p the success, so we are not taking theta, we're taking p. There's a three parameter that we are taking. There is a p1 half. So whatever the sample take value, we are taking the parameter estimation as p equal to 1 by 2. That is not a very good estimation because for every value it can't be equal to 1 by 2. The second, it is taking two values, so it is better than first one, but it is not actually correct because it can value nth value. We are taking only the first two values. That is not a good parameter. Then the estimated 3, what it is doing is that it is taking all the values and getting the mean. So we can say that it is taking all the values and giving us a estimation. So this estimator is somehow we can say good. Now coming to the third part. Now estimator error. So estimator some value is it taking, and now there is a parameter value and then the estimator value, and the deviation between two is that the error. So that is the phi of x1 x2, that is the value, that is the estimator taking, minus the parameter value is the random variable. So now what we can say that we can expect extend a random variable to true value around actual value, that is correct. The parameter should take values around the estimator. Estimator should take value around the parameter, that is a good parameter example. So error should be close to 0. That is also then how we are taking the bounds. So like probability of absolute value of error is greater than delta. So delta is some values greater than delta should be has to be small. So through delta we are taking a bound. So probability of error that has to be greater than 1 or greater than delta has to be small. Okay, then taking about the delta what value should we take? So delta, if you take 0.1, suppose you're taking 0.1, and who can say the parameter value, then it is 0.10 to the power minus 6. So that is not a very good delta value. So delta value, what we can do, delta value we can do as the function of the parameter. So parameter function like 10% of the parameter, like p of by 10, that is 10% of the parameter, that is a good function. Now taking the sample, then taking p1 p2 p3, these are the values we are taking estimated ranks and estimated values, and then we can see that first parameter. So first the taking the variation and boundary type p equal to, that is a parameter that what value it is taking. You can see p is same for all, so এটা ভালো না, then p2 ঠিকঠাক আছে কিন্তু x1 x2 দুটো ভ্যালু নিচ্ছে, that is not a very correct answer. p3 it is taking all the values এবং যেখানে যেখানে চেঞ্জের দরকার চেঞ্জেস করছে. So p3 seems to be very promising for this same reason. p3 should be promising for the same reason. So p1 p3 তিনটা প্যারামিটার আমরা করে নিলাম. দেন এস্টিমেটের ক্ষেত্রে আমরা এখানে যদি এক্সাম্পল দেখি, p1 হচ্ছে 1/2, দ্যাট ইজ কামিং, দ্য এরর ইজ দ্যাট, সো এরর মিনস p1 ভ্যালু that is the estimator value, that is 1/2 it is coming. So you know that the first one absolute value of the error is the estimator value minus the parameter. So parameter is p, estimated value is 1/2. These are all estimated values, 1/2 minus p. So now you can see in the graph, so 5/11 and 1/9, 5/11 নিচে যখন আসছে তখন সেই প্যারামিটার ভ্যালু 1 হচ্ছে. Yeah, that is the something value, that is the p minus 1/2 minus p value, and absolute value of error is greater than absolute value of error is greater than p by 10. is 1. So এখানে যখন ভ্যালুগুলো থাকে সবসময় 1 হচ্ছে, so that is not a good parameter. In the second case also এটাও 1 হবে, কোথায় less than 1/5 আছে, -1/2. So now we are taking the values, we are taking the calculation, and এটাও গুড প্যারামিটার না, সেটা আমরা দেখতে পাচ্ছি না। P3 প্যারামিটার ক্ষেত্রে যেটা দেখা যাচ্ছে, এটাকে x1 এটা মিলে আছে, so error is that x1 x2 dot by n minus p, that is the error. Now expectation of error, that is what is expectation of error, এটাকে linearity of expectation আমরা কনভার্ট করেছি, that is e of x1 e of x2, so that is n ভ্যালু, আর প্রত্যেকটা e of x for Bernoulli is p, e of x for Bernoulli is p, then sum of random variable, that is in p, that is the sample Bernoulli expectation of n, so in p divided by n. So এখান থেকে আমরা p আসছে p minus p equal to 0, so that's why it is coming as 0. Now probability of error minus 0 greater than less than, এখানে আমরা কী করেছি ডেল্টাকে আমরা কীভাবে নিয়েছি, লেস দেন ভেরিয়েশন অফ এরর বাই সিগমা স্কোয়ার, ভেরিয়েশন আমরা ফর বার্নৌলির জন্য p into 1 minus p by n, simple thing. Then what you can, p of e equal to 0, then probability estimate is greater than parameter at 10%, so p by 10 equal to the value we are putting, and then it is coming as this. So for a fixed p, the above probability tends to 0 as n tends to infinity. So how? Above probability tends to 0 for p if we fix, now n value is greater than, you are getting to infinity, that's why it is coming as 0. So p একটা ফিক্সড ভ্যালুর জন্য আছে, এখানে যে স্যাম্পল ভ্যালু আমরা যত বেশি যাব, তার মানে কি আমরা দেখাচ্ছি একটা এস্টিমেটের মধ্যে যখনই আমরা স্যাম্পল ভ্যালু বাড়িয়ে দিচ্ছি তো 10% এরর আসবে, সেটা খুবই কমে যাচ্ছে। সো আমরা যদি 5টা স্যাম্পল নিই, সেখানে আমরা 10% এরর আসার ভ্যালু সেটা হচ্ছে 100 into 1 minus p by np, দ্যাট ইজ রাইট। বাট হোয়েন উই আর টেকিং 1000 1 lakh স্যাম্পল, দেন দ্য প্রবাবিলিটি, তখন আমাদের ক্ষেত্রে সেটা অলমোস্ট ক্লোজ টু 0 এসে যাবে। তো দ্যাট ইজ এ গুড প্যারামিটার নাও উই ক্যান কনসিডার, বিকজ as probability of estimator is getting closer to 0, that's what we want. So Cheryshev, Chernoff and concentration phenomena, these are all those are helpful. সো এখানে লাস্ট পেজ আমরা দেখে নিচ্ছি, প্রবাবিলিটি একই জিনিস আছে, গুড ডিজাইনের কী আছে, এস্টিমেটার শুড বি ক্লোজ টু ইকুয়াল টু রিয়াল ভ্যালু, দ্যাট ইজ 0, and ভেরিয়েশন অফ এরর শুড বি 0 উইথ n, টেন্স টু 0 উইথ n. সো মানে কি, ভেরিয়েশন অফ এরর যত আছে 0তে আসতে হবে যখন n ভ্যালু ইজ গেটিং ইনক্রিজড, increase how much, the more the n value, that has to be close to 0. Now